Hello again. Thank you for watching this video and studying math with me. Today our topic is going to be factors, and this are the learning objectives. You want to identify factors, be able to do the difference between prime and composite numbers, and find prime factorizations. Let's begin with some definitions. Factors of a number is defined this way. A factor is a whole number that divides exactly into a whole number. There is no remainder. And the divisibility test that we studied earlier, especially the ones for these numbers, are going to prove very useful as you go forward and do these kind of problems. And what follows is another opportunity for you to pause the video and do some work. You want to be an active learner, and so test these and then watch the solutions as we go forward. So here is the first set of things. We want to find all the factors of each number. Now we're back again. Let's find the factors of each number. And so here I say I can go 1 times 18, 2 times 9, 3 times 6. 4 won't divide into it, 5 won't divide into it, and 6 will divide into it, but that brings us back to here. So the factors of this are 1, 2, 3, 6, 9, and 18. Notice that 1 and 18 are factors. Let's talk about 50. I can go 1 and 50. I can go 2 and 25. 3 doesn't work, 4 doesn't work, 5 does work, and it's 5 times 10. 6, 7, 8, and 9 don't divide into it, so then we come to 10, so we found all the factors here. 1, 2, 5, 10, 25, and 50. Now here is the next number is 109, and we could try to find factors of 109, and certainly we can go 1 and 109, but we find it's not an even number. 2 doesn't go into it. 3, 4, and so on and so forth. And we could test all the numbers. Well, you find the only numbers that go into this are 1 and 109. This is what we're going to call a prime number later on. The last example is 44, and 44 is going to be 1. See, I have to move this over so you can see. Is 1 and 44. It is 2 and 22. 3 doesn't go into it, but 4 does. 4 goes into that 11 times. And if you start checking 5, 6, 7, 8, and 9, and 10 don't go into it, so 11. So these are all the factors of 44. It's going to be 1, 2, 4, 11, 22, and 44. So we end up with several factors there. Now, of special importance are the prime numbers. A prime number is a whole number that has exactly 2 different factors, itself and 1. That's the only way you can factor. So 3 is a prime number, but because 3 and 1 is the only way to get 3, but 8 is not a prime number because you could take 2 times 4. Now 1 is not a prime number because 1 is not times 2 different factors. So the number 1 is not a prime number, so one should remember that. And another observation to make is that all prime numbers are odd numbers except the number 2. 2 is the only even prime, but not all odd numbers are prime numbers. For example, 9 is 3 times 3. That's not prime. Numbers that are not prime are called composite, and the numbers 0 and 1 are neither prime nor composite. They're special. So numbers can be 0, 1, prime, or composite. Now, a prime factorization of a number is a factorization in which every factor is a prime number. And it is an important theorem in math that every whole number has its own unique prime factorization. The order of the factors may differ, but the factors themselves will be unique to that number. So we're coming upon another opportunity for you to do some work to test your understanding. What you want to do is pause and do these examples. Okay, and when we return, we'll work on them. Okay, we're back. This is prime. This is prime. That is neither. This is composite. This is composite. This is prime. This one is prime. I'll move over so you can see that prime, and this one is composite. If we want to find the prime factorization of each number, we'll do that. This is 2 times 3. Both 2 and 3 are prime factors. This one is 2 times 31. Both of those are prime factors. Now 20 is 4 times 5, but that is 2 squared times 5. 13 is prime. There is no prime factorization of that. This one is 2 times 49, but 49 is 7 squared. So that one is 2 times 7 squared. This is 2 times 39, but 39 is 3 times 13. So this is 2 times 3 times 13. That's the prime factorization. This next number is 4 times, and then it is 21, and 21 is 3 times 7, so the prime factorization of this is going to be 2 squared. That's how you get the 4, 3 times 7. And 95, I'll move down so we can see that, 95 is going to be 5 times 19. So that is the prime factorization of all those. The serious student, of course, will want to read this section in your book and the examples found in your textbook and do enough problems to feel comfortable with things. But for now, remember, time is precious. Each day must count. Do the math. It will make you strong. Take care and see you in class.